So, on Friday we looked at very basic vector addition. We also looked at the general principles of vector addition. Right? Those general principles, if you recall, were that when I draw a vector, the length of the vector represents its magnitude. The direction the vector is pointing obviously represents the direction, so this would be 10 kilometers east. Okay? If I was to draw a corresponding vector that was 5 kilometers at 30 degrees south of east, it would look like this. I would draw a dotted line, maybe using a different color so you can see it. Okay, a dotted line, okay, going east, then a line going 30 degrees south of that. That is half the size of this one because it's supposed to be 5 kilometers long, okay? And the length of the arrow represents the magnitude, right? Then I would put in the direction here, 30 degrees, and I'd have my two vectors drawn. So that's tail to head, okay? That's the way we draw our vectors, is tail to head. Length represents magnitude, and they need to point in whatever direction the vector is given. Is that ringing the bell from Friday? Okay. On Friday, we dealt with collinear vectors, which you've already done from Science 10. Okay, it's forward and backward, up and down, positive and negative. And then we did some perpendicular ones, where we had to bring in a little bit of trig. Today will be much more trig intensive than Friday, because now what we're going to be doing is turning every one of our vectors into an x, or horizontal component, and y, or vertical component, which will involve us having to use trigonometric functions to calculate their values, right? And so that's the first thing that we're going to look at, so that we can see kind of how that's all going to work. So that's the first part. Learn how to resolve a vector into its components, and then secondly, learn how to use vector components to add vector quantities that are not collinear or perpendicular, because obviously that's what we did on Friday. All right. So if I want to resolve a vector into its components, okay, really all I'm doing is taking a vector like the blue one here, okay, and figuring out how far over it goes, which would be ax here, and how far up or down it goes, which would be represented by ay. Everybody follow me there? Okay. Now, how many pieces of information do I need to know about a triangle in order to find out everything there is about it? 2. I either need 2 sides, or I need an angle and a side. Okay? From there, I can calculate everything else about that particular triangle. Right? We're always going to have a side and an angle in this case, because we're always given magnitude, the side, and direction, the angle, for any vector quantity. Right, so if I'm looking at this one here, and let's say that for this vector, they tell me that it is, 50 meters, 30 degrees north of east. Right? So it makes a triangle like the one that's drawn here, where AX is the horizontal component and AY is the vertical component, how far over and how far up it goes. Okay? So what part of the triangle do I know? What do we call the longest side? The hypotenuse. Okay, so I know the hypotenuse, and I know one angle, which means I can use sine and cos to get the other 2 sides, and that's what we have to do. Right? So I'm going to find the other 2 sides of this triangle using those 2 trig functions. Which trig function am I going to use to find the x component, this side here? Nope. No, I have to have opposite and adjacent to use that one. Okay, so is this side adjacent or opposite the angle? It's adjacent. Which trig function deals with the adjacent side and the hypotenuse? Cos. Okay, so we got to remember this. We got to remember our, okay, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Right? So I got to remember that so I know which trig functions will help me calculate which sides. So I'm going to use cosine to get my x component because x is adjacent to or touching the angle that I was given. And I know the hypotenuse. So to find x, okay, I'm first going to set up like this. I'm first going to say the cos of 30 degrees, because that's the angle I was given, equals the adjacent side, which I don't know, divided by the hypotenuse, which is 50 meters. So what do I need to do in order to get the adjacent side by itself?
Times by 50 meters.
Right. So I'm going to have the cos of 30 degrees times 50 meters equals the adjacent side. Right, so when I punch that into my calculator, it's going to be 43 point something. Okay, so cos of 30 times 50. Oh, 40. Yeah, 43. 40. All right. 43.301. Should I keep all of the decimals from a significant digits perspective? I should. Okay. Keep all of the decimals till the very end. Okay. Your calculator, you can go back up and grab them whenever you want. So it's really easy to keep all the decimals. You don't have to write them down. I never write them down because it's a pain in the neck. Okay, I just go back, I write like 3 of them, and then that's good enough. All right, so my adjacent side here is going to be 43 point, it was 301, right? Yeah, 301 meters east. Right, now, which trig function am I going to use to get the y component? Sine, because it's the opposite side, and I have the hypotenuse. So in a similar calculation, I would say that the sine of 30 degrees equals the opposite side divided by the hypotenuse, which is 50 meters. So when I go sine of 30 times 50 meters, that will give me the opposite side, which is going to be 25 meters north. Are you impressed? I just did trig in my head. Don't be impressed. The sine of 30 is 0.5. It's just one of those ones I've memorized. I use 30 degrees all the time because it's one of the ones I remember. It makes me feel cool. Which tells you how nerdy I am. That trig can make me feel cool. Yeah. Okay, 25 meters north. So now I know the two sides of this triangle. I know this one is 43.301 meters, and I know this one is 25 meters. Okay? Now I know how far over and how far up that vector I was originally given goes. Okay? Now, because I haven't told you the whole story, you're probably looking at that and going, so how does that help me? Okay? Here's how it's going to help you. We're going to be working on questions like this today. Where we're going to have to add those two vectors together. They're neither collinear, nor are they perpendicular. So if I was going to draw a line, so this is my starting point right here. This is my ending point right here. Where would I draw a line that shows my overall displacement?
Between the start and finish.
Right, between the start and finish. So this line, even though I do this, from a vector perspective, this is how much I have displaced myself. This would be my overall displacement, its magnitude and its vector. Okay, so here's why we need to be able to find x and y components. If I want to find out how big D is, I need to know how far up and how far over I have gone over the entire trip. Finding the x and y components of the two parts of the trip will help me to do that. Okay? In this first part of the trip, I go east. Okay? Red x is pointing east. Right? So I go east a certain distance. And then, in the second part of this, I come back to the west a little bit. If I add these two numbers together, taking into account one's east and one's west, what I'll get left over is blue x. How far east or west, in this case east, did I end up going over the whole trip? Okay. Similarly, in both of these vectors, I went north. And I could calculate how far north did I go in the red one, how far north did I go in the green one, and if I add those two numbers together, I'd get blue y. Now I would have two sides of my displacements triangle. And we just finished saying that as long as I know two sides or an angle on the side, I can calculate everything else about that. So I could calculate now the hypotenuse using Pythagorean theorem, and I could calculate the angle using trig. And then I would know what my overall displacement, magnitude, and direction would be. Right? So this is why we need to be able to, what we call, resolve a single vector into its x and y components. Because we can use those to get the big picture. You don't need to draw that yet. We're going to do one like that in a few minutes. All right, so that's what we just did. Find the x and y components. Okay, we used some trigonometry. So to find the x component here, this is what we did. We took the hypotenuse, A, and we multiplied it by the cos of theta. We said it was 30 degrees. Okay, so we went 50 times the cos of 30, and we got that side. Okay, and then we did sine on this side because it was the opposite side. So we said, all right, we're going to take the hypotenuse, which was 50 meters, multiply it by the sine of 30 degrees, and we got this side of the triangle. Obviously that triangle is not a 30-degree triangle, but that's what we did. Everybody all right with that idea? Okay. I know right now it's probably feeling a little bit overwhelming, but don't worry, we're going to get lots of time to practice this and work on it. All right, so this is what we did, but now we're going to do it with these angles instead. All right, so if I want to find what D is, or sorry, if I know what D is, it's 175 meters, okay, and it's angled 50 degrees above the horizontal. What are x and y? Okay, so again, x is which side, opposite or adjacent? It's adjacent, okay, and the y is the opposite side. So if I want to find y, okay, I take the hypotenuse, D, I multiply it by the sine of 50 degrees, so I take my 175, multiply it by the sine of 50, and I get 134 meters. Okay, so I know this side here is 134 meters. If I want to find the horizontal component, okay, it's the adjacent side, so I go D times the cos of theta, so 175 times the cos of 50, I get that side's 112 meters. Okay, and now I've resolved that vector into its horizontal and vertical parts. Okay. It won't take long and you'll be doing this like that. Okay? Just a matter of getting the trig muscles back in shape. Questions so far? So, this is kind of what I was drawing for you before. I don't know if this diagram is more or less confusing. It is certainly more busy, okay, than what I drew. But all right, if I've got two vectors, A and B, okay, A happens first, B happens second. I draw them tail to head like this. Okay, A goes this much over and this much up. B goes this much over and this much up. Okay? But if I take the, okay, but if I take the y component of A and add it to the y component of B, I would get this. How far up in total we went. And if I take the x component of A, this one here, and add it to the x component of B, I would get this line, which is how far over I went in total. And then again, I would have the two sides of the triangle, and I'd be able to find out the magnitude of the hypotenuse and the angle of the hypotenuse. That's what we're looking at. All right, I want you guys to copy this one down, and we're going to walk through it together. Now, believe it or not, the hardest part is done for you. The diagram is already drawn. That can be tricky, okay, drawing the diagram. In this case, it's already drawn. So I'm going to give you a couple minutes, get the question written down and the diagram drawn, and then we're going to walk through how we solve it together. So on a question like this, normally you wouldn't have the diagram. You'd be required to draw it. Okay, so I'm going to kind of walk through that process as well before we get to actually breaking it down into x's and y's. Okay, so the first step in any vector component addition problem, that's what this is, x's and y's are components. Okay, we draw the diagram. So it says vector A has a magnitude of 145 meters and is oriented 70 degrees above the horizontal. Right? Now, if it was me drawing this, right, I would draw the triangle with the 70-degree angle. The reason they didn't do that is because it would have made the diagram look really crowded. Okay? So what they did is they drew this vector here, and they said it was 145 meters long. Okay? They didn't label that. They should have. And then it's 70 degrees above the horizontal. So for me, I would have drawn this angle, written the 70 degrees here, and drawn the triangle like this. Okay? There's a reason they didn't do it that way. Now it's overlapping half my diagram. Okay? So I get why they didn't draw it that way. Is it okay for me to draw the triangle the way they drew it? As long as I use what for my angle? Nope. What's this angle here? 20. Right. It's okay to use that triangle as long as, yeah, everyone wants to say 30 because we always think it's 100, right? But it's 90. Okay. So this is a 20-degree angle here. So that's fine. That's the way they've got it drawn. It's actually neater to have done it that way because it doesn't crowd the diagram. So we're going to run with that because that's the way our picture goes right now. Okay. So what they've done is they've drawn that first vector and its component triangle. Okay. The second vector has a magnitude of 105 meters and is 35 degrees below the horizontal. So when I'm drawing these vectors out, what I do is I draw a line that's my reference line. The angle is measured below the horizontal. So I draw a line that's horizontal, like this. Okay? And then I go 35 degrees below that, and that's where I'll draw my vector. So it's 105 meters, it's 35 degrees, okay? And then I complete the triangle. So this is going to be my y component, this is going to be my x component, this will be my y component, this will be my x component, and this red line will represent my resultant. In this case, the total displacement. These are both displacement vectors. Right? So then they drew this line here, and they said, okay, this line represents the overall displacement. It has an x, a y, and a vector. And I don't know any of them yet. Okay. So how will I go about getting red x and red y? The answer is I use the two vectors that I do have information for, right? I use the blue vector and the green vector in order to figure out how far over blue x plus green x and how far up blue y plus green y, okay, it goes in total, and then I'll have the two sides. All right, so first step, draw the diagram. Second step, calculate the x and y components of your vectors. Okay, so that's what we'll do next. All right, I want to calculate blue x. Now, in the triangle I have drawn, is blue x adjacent to or opposite the 20-degree angle? Yes, it's opposite. Okay, which trig function do I use if I have the hypotenuse and an angle and I want to calculate the opposite side? sine. Okay, so x is going to be the sine of 20 degrees times the hypotenuse, 145. So you know where I got that from, because I did skip this step. Okay? The sine of 20 degrees equals the opposite side divided by the hypotenuse. Okay? All I did was move hypotenuse over to this side to isolate the opposite side. X is the opposite side. Okay? So this is just already manipulated. You all right with that? Now, what mode does your calculator need to be in for this? Degree mode, yes. If it's in radian mode, you're going to get very different answers that will make no sense whatsoever. You should recognize when you get them that they make no sense whatsoever. Because I have had people who have left their calculator in radian mode and written down absolutely ridiculous answers because they didn't understand what they were doing. Okay? So really make sure that your calculator's in degree mode. Hit the mode button. Okay? Check it. If you don't know how to do that, go sine of 90. If it doesn't come out to 1, it's not in degree mode. Okay? All right. So I need to calculate what x is by going sine of 20 degrees times 145. All right. So blue x is going to be 49.59. I'm just going to write 593, but I'm going to keep all those decimals, okay, for right now. Meters, and it'll be right. Okay. Okay. I know they didn't give right in the question. It's along the positive x-axis. For me, that's right, so I'm just going to write that. Okay. All right. I want to calculate blue y. Adjacent or opposite the 20-degree angle? Okay. Here's blue y. Here's the 20-degree angle. Is it adjacent or opposite? We already did the opposite side, so this one is adjacent. Okay? If it's touching the angle, it's beside it. That's what adjacent means, beside. Okay? So we're going to have the cos of 20 degrees times 145 in order to get blue y. Okay, so 136.255. I'm just going to say up. It's positive for right now, but I'm going to write up. All right, so now I've figured out these two sides. I know this side's 136.3. Okay, I know this side is 49.59. Okay, so I've got those two sides. Now, I need to do exactly the same thing for the green triangle. Right? So, for the green triangle, is x, green x, adjacent to or opposite the angle I know? Okay, so it's adjacent, right? Green x is right here. It's beside the angle, so it's adjacent to it. Which trig function do I use for the adjacent side? I know the hypotenuse, so I know h, and I know the angle. So I use sine, cos, or tan. Cos, yeah. Okay. Cos is adjacent over hypotenuse. All right, so I'm going to go cos of 35 degrees times my hypotenuse, 105 meters. All right, so that side is 86.01 meters right. Which would then make y the opposite side, because I just calculated the adjacent side. So y is opposite the angle, right? It's not touching it, so it's opposite the angle. That means that for y, I'm going to go sine of 35 degrees times 105 meters. Okay, so that side is 60.23 meters. But it's down. Okay, green y, right, is pointed this way, downwards, okay? Whereas blue y was pointed upwards. So it's important to put something on there to tell you that for me. All right, so now at this point, I know how far over and how far up and down both vectors go. Now I can use that to figure out how far over and how far up or down I go in total. That's red x, how far over in total, and red y, how far up in total we go over the whole trip. Okay? So my next step, now that I've found all of my components, is to add the like components. That is, add the x's together to get my overall x, and add the y's together to get my overall y. Okay, that's the next step. So that means that red x is going to be the sum of blue x and green x, which makes sense, right? I mean, if I look at those two put tail to head, they're the same size as red x. It would make sense to add them. Okay, so red x was 49.593. Plus green x, which was 86.01. Now, I kept all those decimals in my calculator, and I did that on purpose for this step. So I'm going to go with that one plus that one. Okay, that will give me my overall x component. So in total, over this trip, the object goes 135.603 meters to the right, or along the positive x-axis. Okay. The next thing I want to calculate is my overall y, so red y. Now, I still add. This is, after all, called vector addition. But one of these is up and the other is down. So one of them needs to be negative. So I'm going to make blue y, which was 136.255, the positive one, because up is generally positive. Okay, so 136.255 plus negative 60.23. You could just subtract if you want. Okay, so in the end, we still end up 76.03 meters above where we started. Okay, and just so that you're not confused here, this was blue y, and this was blue x, okay, and this was green x, and this was green y, okay, just in case you're trying to trace everything. All right, so now I can say that this is 135.603, and this is 76.03. Can I now calculate D, my resultant, which is the overall displacement, and its vector? I can. how would I calculate how big D is? I've got two sides of that triangle. I'm looking for the hypotenuse.
A squared plus B squared equals C squared.
Exactly. Use Pythagorean theorem. A squared plus B squared. I have those. It'd be x squared plus y squared, but it's the two sides. They're going to add up and give me the hypotenuse of the triangle. So that's my next step. I've calculated the sides of my resultant. Now I can calculate my resultant's magnitude using Pythagorean theorem. So D is going to equal, okay, x squared, red x squared plus red y squared, which in this case will be 135.603 squared plus 76.03 squared. Again, not using the rounded off values. I'm going to use all the decimals from my calculator. I'm just not writing them all down. Okay, so my resultant's magnitude, or my overall displacement, is 155.464 meters. Okay, so now I have the magnitude of my displacement. Now I need to find the vector, or the direction. So, how do I find theta?
You can always, you can use tan or some close.
Yeah.
Fine.
Exactly. I can use any trig function I want at this point because I know all three sides of the triangle. So whichever is your favorite, you can use. I have no preference from you. My preference is tan because that's my favorite trig function. Because I'm that nerdy, I have a favorite trig function. Okay? So I'm going to use tan. So I'm going to use the opposite side and the adjacent side in order to get theta. Okay, so that's my last step. Theta equals, okay, tan to the minus 1 of the opposite side, which for me was 76.03, divided by the adjacent side, 136, sorry, 0.255. Oh,
Use 35.
I used the wrong one. That's 135.
It is
135. Where did I get the 136? Oh, that was okay. Never mind. I know where I got it from. My mistake. 135.603. See, it's easy to get confused. You got to make sure you write it all down. Okay, so opposite. That one's opposite. Divided by that one, which is the adjacent side. All right, so I'm getting an angle there of 29.278 degrees. Okay, and I have to put a direction on that. The question told me above and below the x-axis, so that's what I'm going to go with. Okay, according to my diagram, that's above the horizontal. Okay, so now I have the magnitude and the direction of my resultant, of my overall displacement. Now I need to write the answer with the correct number of significant digits. So I got to go back to the very beginning. 3 significant digits, 3 significant digits, 3 significant digits, 3 significant digits. How many should my answer have? 3, yeah. Okay, everything had 3, so my answer can have 3. So now I look at what I have, okay, which was the 155, right, 155.464, so that's just going to be 155. Okay, at 29.3 degrees above the horizontal. Could there be another correct answer? The answer is yes. Because I could have drawn my resultance triangle the other way, meaning I wouldn't get 29.3 degrees, I would get the complementary angle to that, which would be 30.7 degrees from the vertical axis, from the y-axis, okay, or right of vertical. Right, so it is possible to get two different vectors. There isn't a different possibility for the magnitude. That would be the same for both. Okay? Is that a lot of steps? Kind of. And it took us, kind of a long time, because it's the first time we did it, right? And for the first little while, they are going to take you a long time. But here's the thing. It's always the same steps. Draw the diagram. Find the x's and y's. Add the x's, add the y's, Pythagorean theorem, trigonometry, final answer. 7 steps, every single time. Same 7 steps. Okay? All that can change is if I give you 3 or 4 vectors instead of 2. The steps don't change, it's just the number of x's and y's you have to find increases. And I'm not going to do that very often, like mostly just to mess with you. Okay? On a test, I would give you, a much easier one. In fact, every year on the unit exam, I give a question. The vector addition question is like this. One vector is either horizontal or vertical, so you don't have to use trig on it. Okay? And the other one is angle. Okay? So on this one here, the x component would be, if this was 50 meters long, x would be 50 meters, and y would be 0. Okay? So you don't have to do any trig, that makes it fast. Okay? This one here, you would have to calculate on this one, okay, what x and y are. That way I know you know how to do it, okay? And then you put it together. Right? So on a unit exam, you get one that's like that. One vector would be either vertical or horizontal, so you don't have to do trig on both. Okay? So it makes it faster. All right. How many people are now, like, the wheels have, like, ground to a stop? Yeah. Some people are yes, some people are no, that's okay. All right, I'm going to give you, like, a 5-minute break. Okay? Decompress. Right? If you're going to the bathroom or using the water fountain or whatever, okay, please make sure you're quiet in the hallway. Back here for 108. So for question number 1, okay, they tell us a hiker's displacement is 15 kilometers at 40 degrees east of north. So my reference direction is north, exactly. Okay, so when I want to start this one, I'm going to draw a line that's north. Then I'm going to go 40 degrees east of that. Okay, and then I'm going to draw a 15-kilometer vector. Okay, sorry, this is 40 degrees. I know what it is, 40 degrees. So this side here, would this be y or x? Y, it's vertical, right? Just like on a graph. Okay, the y-axis is the vertical one. Okay, and this would be the x component. In this question, they want to know what is the north component. So which one's north, y or x? Y. Yeah, y is the one that points north, right? So how do I want to go about calculating y? Which trig function will I use here? Cos. Y is adjacent to the 40-degree angle. So I'm going to go y equals cos of 40 degrees times the hypotenuse. Again, just in case you're wondering where I get that from, right? We know that the cos of theta equals adjacent divided by hypotenuse. All I've done is manipulate this for the adjacent side. Y is the adjacent side, and I multiplied the hypotenuse by both sides. Okay, so it's cos of 40 times 15, right, which will give us 11 kilometers north. Okay, so that's just finding x and y. Okay? It's not as involved as the one we just did. It's just one small part of what we just did. Right? So is number 3. All they're wanting there is for you to find one of the sides of that vector's triangle. I'm going to give you guys a few minutes to try number 3 on your own, and then we'll walk through it together. So as I said, sometimes the drawing can be the trickiest part, okay? Because it does take a bit of practice. So we have a snowmobile that travels 65 kilometers. The direction is 37 degrees east of south. So what's my reference direction? South. We're going east of south. So we're going to measure this from south. So I'm going to draw a line that's south. That will be my y component. I'm going to go 37 degrees east of that. So that'll be 65 kilometers. I didn't draw that very well. Okay, and this is 37 degrees. Okay, so there's my triangle. That's always how I draw it. Now they want to know how far east does it travel. Am I looking for y or x? X. X is the one that points east. Okay, so that's the one I want to find. And is it opposite or adjacent to the 37-degree angle? It's opposite, yeah. So I'm going to use which trig function? Sine. So I'm going to go sine of 37 degrees times the hypotenuse, 65 kilometers, and that's going to give me 39 kilometers east. Okay, everybody all right with finding the components? All right. Now, with regards to number 2, we don't do questions that have the rectangular coordinate system. Okay? That's why you see this angle is 245 degrees, and it makes no reference to any direction. Okay? That's when you start with the x-axis being 0, okay, degrees, and then you go clockwise around to 360. We don't do that. Okay? We use compass directions, or we refer to from the x-axis, positive x, negative y, whatever. Okay, we refer to those. All right. I'm not going to do number 1 because that's got rectangular coordinate system. But let's have you guys try. Let's do number 3 first. Okay, do number 3 first because it's more like what I would give you on a unit exam. Now, the thing you need to be aware of with question number 3 is when you draw your diagram, scale is important. Okay? You need to represent length and angles somewhat accurately, or your diagram will tell you a lie. Okay? Your math will tell you the truth, and your diagram will lie to you. Okay? So make sure that you get the scale about right. I'll give you a few minutes, and then I'll draw the diagram so you can confirm that you have it right. Just so you've got the diagram, we're going to draw the diagram on here. So my first vector is 300 meters due south. So this little blue dot is going to be my initial position, or my starting point. I'm going to go 300 meters due south. All right, here's where scale becomes important. My next vector is 550 meters. That's almost twice as long as my original vector. And it's 75 degrees north of east, so it's very steep. Is it going to go higher than this first point? Definitely. I have people who draw this like it miraculously goes right up level with that and makes a perfect right angle triangle for them to use. You will never be that lucky. Okay? It just won't ever. You won't ever be that lucky. Your luck's not that good. Okay? This has got to be to scale. So I'm going to draw a line that is due east because that's the reference direction they gave me. I'm going to go 75 degrees north of that. And then I'm going to draw my 550 meter long vector. Okay, I didn't measure that, but the scale is close enough that my diagram is going to reflect what my math is going to tell me when I'm done this question. Okay, so this will be red x, this will be red y. Where do I draw my resultant? They want me to find the displacement. The displacement is my change in position. Yeah, from start to end. This is my initial position. That's my final position. So the green line would represent my overall displacement. It will have an x component, a y component, and a vector. All right, you guys can keep working. Remember, your next step is to find all the x's and y's. Then you add the x's together, add the y's together, find green x and green y. Pythagorean, and then trig. Okay. Give you a couple minutes. By a couple, I mean like probably 10 or 15, because we have that much. Okay, and hopefully we'll finish this one up before class is over. So, first step after drawing the diagram is to calculate all the x components and all the y components. For this one, that's a little bit shorter because our first vector is due south, which means the x component for that one is, does it go sideways? It doesn't. It doesn't go east or west, so its x component is 0. It's strictly vertical. Okay? And its y component then is not 0, 300. Right? I mean, it goes 300 meters due south, so its y component is 300 meters south. That's the only direction it goes. Okay, I do have to do a little bit of trig for the red vector because I've got an angle for that one. Right? So red x is the adjacent side to my 75-degree angle. So I'm going to use cosine to get x. So that'll be the cos of 75 times 550 meters, the hypotenuse. Okay, so that side's going to be 142.35 meters. East. Okay, and then my y component is opposite the 75-degree angle, so I'll be using sine for that one. Sine of 75, okay, times 550 meters. All right, so that one's 531.26 meters. North. Again, I'm rounding off there, but I'm not rounding off in my calculator. I'm keeping all the decimals for the purpose of significant digits. Okay, now that I've got those, now I can use those to calculate green x and green y. Green x is really easy. There's only one part of this trip where I go east or west, and it's right here. Okay? If I'm looking at this thing here, it's a rectangle, is it not? That means that red x and green x are the same. All right, so green x is going to be 142.35 meters, and that is going to be east. All right, everybody okay with that? Now, for the y I've got to do a little bit of work there. Okay, green y, we go 300 south, and then we go 531 north. Okay, so on this one here, I'm going to have negative 300 plus 531.26, which is going to give me 231.26 meters north. Okay, everybody following me so far? Right, because I went south in the blue and north in the red, so my y component is smaller than both of them because I backtracked. Okay. All right, now that I have the two sides of the green triangle, y and x, I can now calculate d. Right, so d will be the square root of my 142 squared plus my 231 squared. Okay, again, I'm only rounding off on paper. I'm not rounding off here. All right, so so my overall vector, miraculously, comes out to a whole number with no decimals. That was a lucky guess. Okay, 550 meters. Okay, whoop. Oh no, wait a minute. Did anyone catch what I did there? You know why that worked so well? Because I'm an idiot. Nobody said anything. Okay, because I put in the x and y components for the red triangle. That would be why that worked out so well. Okay, let's try that again. And be less stupid about it. Entry, not 531, but 231. That will come up with it. There we go. 271.559. Meters, okay, and then I've got to calculate the angle. Since I know x and y and that side, I can use whatever I want. I'm going to use tan to the -1. The opposite side for me is the x component, which was 142. Okay, and my y component is the adjacent side. That was 231. Don't worry, I'm going to change it. I won't forget this time. Oh, and I put it in the wrong place. Let's try that again. All right, so we're getting 31.6 degrees for that. Okay, and what direction is that 31.6 degrees for me? Close. East of north, yeah. Okay, remember, my reference line is north. That's going to be my second direction. I'm going east of north. Right? Now, if I drew the triangle the other way, which could totally happen, if somebody drew it like that, then you're going to get 59.4 degrees north of east, which is fine. Perfectly acceptable answer. It's exactly the same direction. All right, so when this is all said and done, how many significant digits do I have? 2. The 75 has 2 significant digits. Okay, so their answer here is actually wrong. Okay, it should be to 2 significant digits, so it should be 2.7 times 10 to the 2 at 58 degrees, or, okay, for us 32 degrees. Everybody with me there? Okay, I know this is kind of overwhelming, but don't worry, we're going to spend lots of time on this before we move on to something else. Okay? So remember, acceleration labs due on Thursday. Make sure you have those done. And tomorrow's quiz will post at 3:20. It will have one perpendicular vector, so nothing like this. Okay? A perpendicular vector and a graphing question. So it shouldn't take you too long.